Good day, kings and queens. Welcome to our video class in mathematics. I am your humble tutor, Mr. Kamal. Stay with me as I take you through this. Of course, today we're going to learn some things that are likely and unlikely in mathematics. That's what we're going to learn today. And this is called probability. Okay, so that is the topic we're going to learn today. And in mathematics, there are certainties. Okay, for instance, if you have 2 plus 2, okay, in mathematics, we already know that 2 plus 2 will always give you 4. When you multiply 2 by 3, of course, it will always give you 6. Okay, but in the real world, there are events that are unpredictable. We have some events that are unpredictable. Okay, and for instance, if you flip a coin, okay, a coin, it either comes up with the head, okay, or the tail. That is when you what? Flip a coin, or when you toss a coin. Okay, for instance, in football matches, if the referee wants to decide the team that will kick off by passing, they'll start by flipping off the coin. Okay, so it's either the head comes up or the tail comes up. Okay, now what is probability? Okay, what is probability? What is probability? So we have to look at the definition of probability. Okay, now I can say that probability, okay, or chance, probability or chance, right, is a measure of the likelihood. It's a measure of the likelihood. It's a measure of the likelihood of an event happening. Of an event, okay, happening. Of an event happening or not happening. Can you see that? Okay, we have to look at this again. Probability or chance, we don't want to call it probability, we can call it chance. Okay, at times another word for probability is chance. It's a game of chance. It's what? A measure of the likelihood of an event happening or not happening. That is our definition of probability. Okay, now of course there are some events that are likely to happen. Okay, there are some events that are likely to happen, whereas there are some other events that are unlikely to happen. So we have to take note of this. Okay, likewise the fact that we have some events that are likely to happen, there are some events that are unlikely to happen. Okay, whereas we can also have some events that are very likely to happen or very unlikely to happen. Okay, so take note of that. Now let's try to look at the probability line. Okay, we're going to look at the probability line. Exactly. So in the probability line, it goes from the range 0 to 1. In the probability line, the range is from 0 to what? 1. Now, it is 0 here, that means it is impossible. At 0, probability here is 0, that means it is impossible. At 1, that means it's certain to occur. So that means probability can never be less than 0 and can never be greater than 1. It always falls within this range from 0 to 1. Now, at the middle, you will see that what we have here is half. That means there's equal chance of occurrence. Okay, so here there is what? An equal chance. Okay, equal chance. Equal chance. Okay, for instance, when you flip a coin, it's either the head shows up or the tail shows up. That is either head or tail. So that kind of probability, there is equal chance there. So that is represented by half. Okay, can you see that? Now, at times, there are some events that are impossible. Okay, if you have a die, right, it has 6 faces. Okay, 1, 2, 3, 4, 5, then lastly 6. Okay, it has 6 faces. Okay, of course, if you are conversant with the Ludo die, right, it has 6 faces. Of course, each of these faces is like a keep. Now, if you now roll this die, since we said it has 6 faces, 1, 2, 3, 4, 5, 6, if you roll it once, the probability that 14 appears, rolling a 14 will be regarded as what? An impossible event. It's impossible. Okay, of course, you can't have 14 when you roll this guy. It has only 6 faces. So this is an example of an impossible event because it has just 6 faces. Now, let's take a look at event that is certain. A good example of that in the real world is the sun will rise. The sun will rise. The sun will rise. Okay, so this one is certain. Can you see that? It's certain. Now, what happens when you have probability in between 0 and half? Okay, now any probability that falls here will be, let's say, unlikely. Any probability that falls here will be unlikely. Any probability that is very close to this as around this region, will be very unlikely. Okay, then any probability within this region will be likely. Okay, so that means when you move from this point to this point, you are moving from likely to certain. So, but when you move from here to this other point, you are moving from unlikely to what? Impossible. Okay, so probability that appears very close to impossible, let's say this region, will be very unlikely. Very unlikely. While probability that is very close to 1 here will be what? Very likely. Okay, remember I said probability always fall within the range of 0 to what? To 1. Okay, all right. Now, let's look at the probability formula. The probability formula. Okay, now the probability formula can be mathematically stated thus, or we can state it like this, right? Probability equals to the number of successful outcome, the number of successful outcome, the number of successful outcome, all over the number of total outcome. The number of total outcome. That's the formula for probability. The number of successful outcome over the number of total outcome. So how can you get the number of successful outcome? The number of successful outcome is simply what you are expecting. The number of success. Okay? What you are expecting is the number of successful outcome. But the total number of outcome is like the sample space. It's like what? The sample space. For instance, if I'm going to use a die, for instance, remember it has 6 faces. If 1 doesn't show up, 2 will show up. If 2 doesn't show up, 3 will show up. If 3 doesn't show up, 4 will show up. If 4 doesn't show up, 5 or probably 6. So that means the total number of outcome, for instance in a die, will be what? 6. Okay? For the die, n total outcome will be what? 6. Since it has what? 6 faces. But for the coin, the total number of possible outcome, okay? Total number of possible outcome, you can write it as total number of possible outcome. For the coin, since it's either the head or the tail, that will give us 2 for the coin. Okay, for the coin, it's either the head or the tail. 1, 2. That means the number of total outcome here for the coin is 2. Okay, number of total possible outcome here for the coin is what? Or total number of possible outcome here for the coin is 2. The total number of possible outcome for the die is what? 6. Why? Because it's either 1 appears, 2, 3, 4, 5, or 6. It's either 1, 2, 3, 4, 5, 6 appears. So that makes the total number of possible outcome for the die to be what? 6. Now let's look at some examples to illustrate this concept. Okay, as you can see in this example, what do we have? Example 1. There are 7 red balls, 8 white balls, and 5 blue balls in a box. I pick a ball at random from the box. Find the probability that the ball is A. White, B. Red, C. Green, and D. Neither red nor white. Okay, now with that kind of problem, we're going to look at how to solve this. Okay, and one thing you need to understand is that anytime you are solving this kind of problem, you have to write out your parameters. This is very, very important. Okay, you need to learn how to write your parameters. Okay, now let's try to find solution to this problem. Okay, now solution. Okay, solution. Now in that question, we need to understand that there are 7 red balls. Okay, now I can represent red with capital R, Can you see that? White with W, okay, then blue with capital letter B, okay. Now we do that there are 7 red balls. We can now say the number of red balls is what? 7, okay. The number of red balls is 7, okay. Then 8 white balls, that means the number of white balls is what? 8. 5 blue balls, the number of blue balls is what? 5, okay. Now one ball was selected at random from the box. Find the probability that the ball is white, okay. But before then, we need to get the total number of balls. That total number of balls will be total number of possible outcomes. We can now write the end total will be the number of red plus number of white plus the number of blue balls, okay. This end total is the total number of possible outcomes, okay. So by the time we add this, we're going to have 7 plus 8 plus 5. If we add this together, you have 20 balls, okay. We have 20 balls, right. Now the first one is our target variable is the probability of selecting a white ball. We can now write the probability of selecting the white ball is question mark. This is what? Unknown, okay. This is unknown. The probability of selecting a white ball is what? Unknown, okay. Now you can now see, but from the formula, probability of selecting a white ball will be number of successful outcome over number of, or total number of possible outcome. We can simply see the number of successful outcome is automatically going to be the number of white balls over total number of possible outcomes, okay. So from our value here, the number of white balls is how many? It is 8. The total number of balls is 20. So we can reduce this to the lowest term. 4 goes here 2, 4 here 5. We can now say, therefore, the probability of selecting a white ball is nothing but 2 over 5. Okay, our final answer is going to be 2 over 5. So the probability of selecting a white ball will be the number of white ball over total number of balls, which is the number of successful outcome over total number of possible outcome. Okay, so in that case, it's going to be number of white ball over total number of balls. Number of white balls is given as 8. The total number of balls is 20. So 8 over 20 in terms of fraction, that's 2 over 5, which will give us 2 over 5. That 2 over 5 converted to decimal is like 0.4, which is very close to even chance, okay? Very close to the middle in the probability scale, okay? So that is the solution to that problem, okay. So now let's try to look at the B part. All right, for the B part, we are made to calculate the probability of selecting a red ball, okay. Now for the B part, we can write probability of selecting the red ball is unknown, question mark. That's our target variable. Probability of selecting the red ball is unknown. Can you see that? Now we already know that how many red balls do we have? We have 7, okay. The number of red balls is 7. The total number of balls is what? 20, right? So probability of selecting a red ball will be the number of red ball over total number of balls, which will give us 7 over 20, okay. That will be answer for the B part. Now for the C part, we're told to find what? The probability of selecting a green ball. What probability of selecting a green ball? We can now write probability of selecting a green ball is question mark, that is unknown. Okay, that is unknown. Can you see that? So you can now see from the box we don't have any green colored ball. As you can see, we have the red, the white, and the blue. So we don't have any green ball inside the box. We can now conclude that therefore probability of selecting a green ball will be equal to 0. Why? No green ball. Okay, the only colors we have there is red, white, and blue. Red, white, and blue. Okay, now for the D part, we're told to calculate the probability that is neither red nor white. Neither red nor white. Okay, so this is our unknown. Neither red nor white. Okay, that is what we're looking for. Remember, we have how many colors? 3 colors. We have red, we have white, and we have blue. But the question demands that what's the probability that it is neither red nor white? It is neither red, okay, nor white. That means if it's neither red nor white, it's definitely going to what? Be blue. That means if you didn't select red and you didn't select white, definitely you select what? Blue. Okay, we can now see probability of selecting neither red nor white is equal to probability of selecting blue, because if you don't select red and you don't select white, you definitely select blue. Okay, so I can now see probability of selecting blue is going to be the number of blue balls over the total number of balls, which is the number of successful outcomes over total number of possible outcomes. The number of blue balls is what? 5 over the total number of balls is 20. 5 goes here 1, 5 here 4. That will give us 1 over 4. You see that? Our final answer is 1 over 4. Okay? So that's that. Now let's go to, or let's look at another example. In this example, we're told that a market trader has 100 oranges. A market trader has 100 oranges for sale. 4 of them are bad. I pick an orange at random. What is the probability that it is what? Good. Okay, we can now say solution. Remember, you have to write out the parameters. Okay, we have bad oranges as well as what? Good oranges. Okay, we can now say let bad orange be equal to, represented by capital letter B, while the good orange represented by capital letter G. Can you see that? So we can simply say that here the market trader has 100 oranges. We can now write that the total number of possible outcomes is what? 100. That will be the total number of oranges. Okay, now 4 of them are bad. Okay, now that means the number of bad oranges, B bad, is how many? That's how many? That is 4. Okay, but the question demands that what is the probability of selecting an orange that is good? So that means the number of good orange will be the total number of bad oranges minus the number of what? Total number of oranges minus total number of bad oranges, right? That's going to give us 100 minus 4. That will give us 96. So 96 will be the number of good oranges. Okay, but the question demands that what the probability of selecting good orange? Probability of selecting good orange. So this is what we are looking for. Now together we can now say Probability of selecting the good orange is going to be the number of good oranges, okay, which is, this will represent the number of successful outcomes over total number of possible outcomes. The number of successful outcomes is the number of good oranges. That is 96. I'm going to write 96 over the total number of oranges is 100, and total is 100. Of course, we have to reduce it to the lowest term. So I can simply say 2 can go here. 4 remainder 1. 29 is 4 remainder 1. And 16 will give us 8. Can you see that? 2 in 10 will give us 5. 2 in 0 will give you 0. Okay. Then we can equally say 2 in 4 is 2. In 8 is 4. 2 in 5 is 2. Remainder 1. In 10 is 5. So that's 24 over 25. So we can now conclude that the probability of selecting a good orange is nothing but 24 over 25. But if the question demands that what the probability of selecting the bad orange, of course we can calculate that. What will be the probability of selecting the bad orange? It's going to be the number of the bad oranges over n total. Okay, that will be what number? How many bad oranges we have there? That's 4 over total 100. Okay, as you can see, 2 can go here. 2 in 10 is 5. In 0, 2 can go here. 1 in 5 is 2. In 10, remainder 1 in 10 is 5. So that is 1 over 25. That will be the total probability of selecting bad orange. But the question demands that what is the probability of selecting good orange? Okay, so that is what we have here, 1 over 25. But the question demands that we should calculate this. That's 24 over what? 25. So that's going to be the solution to this problem. Okay, now let's try to look at example number 3. Okay, if you have any problem, you can always pause the video if you miss any step. Okay, now here we're told that a tray of eggs contains 18 large-sized eggs and 12 small-sized eggs. Okay, now someone picks an egg at random. Find the probability that it is A, a small-sized egg, B, neither a small-sized nor a large-sized egg. Now, how can we do justice to this kind of problem? Okay, solution. Can write solution. Remember to always write out the parameters. We are considering large-sized egg and small-sized egg. So I can now say, let large-sized egg be represented by L. Okay. Small-sized egg be represented by S. So we can now say the number of large-sized egg is what? From the question, it is what? 18. 1, 8. While the number of small-sized egg will be what? 12. Can you see that? Now the question demands that what's the probability of selecting a small-sized egg? Can you see that? Probability of selecting a small-sized egg, right? Probability of selecting a small-sized egg, we'll write that as unknown. This is our target variable. Okay, you can now see probability of selecting a small-sized egg will be what? Number of small-sized egg over total number of eggs. Okay, of course we can determine the total number of eggs. That's 18 plus 12. So we can now see the number of small-sized egg is 12, while the total number of eggs will be 18 plus 12. Okay, that will give us, you can now see that will give you 12 over, now let's add 18 plus 12, that should give us 30. Can you see that? So we now take the common factors. 2 can go here, 6. 2 in 3 is 1, remainder 1. In 10 is 5. 3 can go here, 2. 3 here is 5. So our final answer here is 2 over 5. 2/5 is the solution to this problem. Okay, so we can now say, therefore, probability of selecting a small size egg is 2/5. So that is going to be the solution to this problem. Okay, 2/5 is the final answer. Now, in the last question, we're now told that what is the probability that it is neither small size nor a large sized egg, neither S nor L. Okay, since we have just only two types, the small sized and large sized, so the probability of not selecting small size nor large size is 0. Okay, we don't have any other type of any other size there exactly in the tray. Okay, it's just basically two, small sized and large sized egg. So that is that. So that's the solution to this problem. Now, this is going to be your assignment. All right. From the first question, what do you have? A crate contains 15 bottles of Coke and 9 bottles of Sprite. If I choose a bottle at random, what is the probability that it is Coke? What is the probability that it is Sprite? And what is the probability that it is neither Coke nor Sprite? Okay. Now, the second problem. There are 6 red balls and 9 blue balls in a box. Anna picks a ball at random. Find the probability that it is red, blue, or yellow. Can you see that? So that is going to be your assignment. And remember, this assignment is 10 marks. So this is 10 marks. This is 10 marks. Yes, the first 10 marks. So endeavor to send your answers. You can type your solution. You can send a screenshot on via Prodigy platform, and of course, the notes will be sent to Prodigy under resources. I'm going to forward the notes to Prodigy under resources, and you can as well send it via my WhatsApp number. Okay, this is my WhatsApp number, 0806 242 4176. You can as well send it via this WhatsApp number. Okay, remember to maybe I need a clear view. You can snap it and forward it to my WhatsApp number or Prodigy. Exactly, and remember I said it is 10 marks, so you have 10 marks for these assignments. Okay, all right, so thanks so much, and I remain your humble tutor, Mr. Kamal. Always remember to wash your hands regularly, and remember to do your assignments, watch the video, try to digest the content. It's okay. It's bye for now. Take good care of yourself. Bye.